Okay, let's have a look at this next question. This is actually from Gamma, or right here, Gamma, the Gamma text, and it's exercise 13.01, and it's about volume. And it says the textbook, Alpha Mathematics, measures blah, blah, blah. Okay. The books are packaged in cartons that contain 2 stacks of 10 books. The cardboard used for the cartons is 4 mils thick. Calculate the volume of space available for the books inside a carton. So if that this bit here, the cardboard used is 4 millimeters, we can ignore that bit then for this question here. But I can see, look at B, it says, what are the most likely external dimensions? Well, then the cardboard thickness will play a part. So let's go ahead and just mock this up how we could possibly draw it. So let's do that now. So we're going to have, and I'll write here again, this is going to be Gamma. This is exercise 13.01. So we've got, let's have a look. We've got books, and there says they contain 2 stacks of 10. So we're going to have, well, let's have a look at a book first of all. Here is a book. It's going to be so long, so wide, and so deep. So there is a book. Okay, and it looks roughly like that, let's say. Now, the reason I'm drawing 1 is we're going to imagine we're going to have 10 of these suckers. So let's have a look. This is 252 millimeters. And I always think it's quite useful to actually just mock these up just so you can see visually what these things might look like. So this is 200 along here. I won't worry about putting the units in for these ones because it's going to get very messy with all the metrics on here. All right, so you've got 1 of those, but you're going to have 10 lots of these, and you're going to have 2 lots of 10. So you can have one pack, one I suppose, stack, which is going to be this times this times this times 10. And all that's going to be times 2. So let's write that out. So we're going to have the stack is going to be in terms of its volume. It's going to be, so the volume of 1, and I'll put volume 1, is 252 times 200 times 24. Volume of 10 is equal to the volume of 1 times 10, and 2 stacks is equal to the volume of 10 times 2. So I can just take this thing here. So the volume is going to be 252 times 200 times 24, tick, times 10, tick, times 2, tick. So let's see where we land with that lot. And I'm not even going to worry about that in my head. I'm going to do that on the calculator. Let's see what we end up with. Here we go. So we've got 252 times 200 times, what do we got here? 24, oh, that's 25. 24 times 10 times 2, or times 20. And we get, let's write all that in. So we've got, oh crikey, there's a lot of numbers here. We've got 2, 4, 1, 9, 2, 0, 0, 0. So this is a lot. And this is going to be millimeters, yeah? Crikey, do we have to do it in millimeters? Well, if we have to do it in millimeters, then does it say anything different? Oh, we're going to give our answer, though, in square centimeters, it says. I just saw that now. So here we go. Our answer is going to be in, sorry, not square, in cubic centimeters. So, well, that changes things slightly. All right, so we've got, let's have a look, 24192 000. Now, of course, because we've got centimeters are 10 times more than millimeters. Yeah, so let's do it millimeters first. So we've got, what have we got? I'll put some commas here. No, we don't use commas. But when we're changing, and this is the important thing to realize, if we're changing cubic millimeters, and we're changing that to cubic centimeters, yeah? Oh, sorry, these are meant to be cubes. Crikey, that's not good. Cubic centimeters to cubic millimeters to cubic centimeters, because if you take, for example, a cubic centimeter, here's going to be roughly a cubic centimeter, something like this, yeah? Here we go. You're going to have 10 mil along here, 10 mil along here, and 10 mil along here. So we've got effectively one of these is 10 times 10 times 10, which is going to be, well, 10 times 10 times 10 is 1,000 cubic millimeters. Ugh. So we're going to have to just lop off 1,000-fold. So 1 cubic centimeter is equal to 1,000 cubic millimeters, which means this is going to be 1,000 times more than the same thing expressed in cubic millimeters. So this thing here is going to be 1,000 times more than the same thing expressed in cubic centimeters. So I'm going to take off 1,000, so I can effectively cross that off and say it's 24,192 cubic centimeters. And that's how I arrive at my answer. Hope that makes sense, folks.